Good morning, everybody. So I will be talking about how you can autoscale your applications on Kubernetes and make it that simple with Kubernetes Event-Driven Autoscaling, or KEDA short. And there are people asking if there will be a recording, and you will be able to watch this presentation afterwards, but I think it will only be available for 1 day. So you'll have to check it in 24 hours, but you can just use the same links. I'm not sure if Teams allows me to publish this somewhere else. Okay, so I will get started. My name is Tom Kerkhoven. I'm an Azure architect for a company called KEDA in Europe. I'm also an Azure MVP and advisor and have a blog, and I'm one of the maintainers of KEDA. So if you have any questions, just let me know. So in the agenda, we will quickly talk about serverless and Kubernetes. I will introduce what KEDA is, and I will show it in action so that you see how easy it is. And then I have a small slide on the roadmap, but we're basically open to anything. So don't hold back. So if you start using Kubernetes, it's a big beast if you're new to it. And it's really more of a cluster platform as a service in the cloud, really, than a PaaS, in my opinion. So there's a couple of things where basically serverless is a nice place, but it's not that easy to do that with Kubernetes. And as part of Microsoft's vision, they decided to basically allow you to run Azure functions on Kubernetes, so that you don't really have to lock in Azure functions, and you can run them on Kubernetes. Now, it still has to be scaled, for example, and that was the trigger for them to start KEDA, to really make auto-scaling super simple for applications. So this is actually not related to Azure functions anymore. It was more of the trigger. And with KEDA, they're trying to really make it simple to use the same concepts and run them inside of Kubernetes. But you can use KEDA for basically any workloads. And they decided to do this on Kubernetes so that you can basically leverage your existing Kubernetes investments. But how do you scale on Kubernetes? That's the first question. So if you have a look, and this very simplistic schematic, if you have multiple pods running and you want to scale them automatically, you need to use a horizontal pod autoscaler. Now, the problem with those is that they are very good, but they only support metrics from the pods themselves. And I think it's maybe even limited to just CPU and memory. When you want to scale on a different metric, let's say a queue depth, amount of inbound requests, etc., that's not possible out of the box. You need to use a custom metric provider. There's a variety of custom metric providers out there. And once you install the correct one for what you need, it basically starts auto-scaling your workloads. We also have cluster autoscaling to ensure that there's enough capacity inside the cluster, which works well with the HPA. So HPA is application autoscaling. Cluster autoscaler is for the cluster itself. Now, if you're new to Kubernetes, this is already a lot in terms of figuring out what you need to do, but also running the custom metric provider might not always be ideal, or you just don't want to worry about that part. And if you're using multiple dependent systems, that's actually a problem, because in Kubernetes, you can only use one custom metric adapter. So if you're using Prometheus, for example, you can use the Prometheus metrics adapter, but you cannot use the Azure metrics adapter. So you could use a tool like Prometheus to bring the metrics from Azure Monitor inside Prometheus and scale it from there. But actually, then you're basically working around the real problem. So that's where KEDA comes in. So KEDA allows you to automatically scale deployments and jobs based on a variety of scalers that we provide. We have almost 20, I think, out of the box. And we are vendor agnostic, so we have systems from a variety of companies. And basically, we bring you the metrics that you need. You just have to install KEDA, and you can scale on a variety of those systems. In the upcoming version, we will even go beyond deployments and jobs and allow you to scale on anything you want, basically. We have production-grade authentication, meaning you can authenticate by passing environment variables and secrets in Kubernetes. We integrate with managed identity providers such as Azure Managed Identity. We have the same for AWS, and we also have Spiffy on the backlog. And if you're not using if there is no workloads to process, we will also basically scale your workload to 0, which is very important because, as we saw, we are also in charge of scaling the cluster, which means that if you have a lot of idle workloads in the cluster, you're burning a lot of resources for nothing. But with KEDA, we basically scale to 0, freeing up the capacity for other workloads who need them, so that you can save on the amount of clustered nodes, which reduces the cost. A nice benefit is that you could already run Azure functions on Kubernetes, but now you can also scale it with KEDA, while in the past you were in charge of that. So KEDA started as a partnership between Microsoft and Red Hat, but I'm happy to say that as of March, I think, we were accepted as a CNCF sandbox project, and you can read more about that on our blog on keda.sh. And maybe I should post a link to that, so I will quickly do that. In the meantime, don't hesitate to ask questions. I can always interrupt and talk about it. There you go. So our focus is really on making it simple to scale your application without having to worry about any of the scaling internals, let's say. Frankly, you should not need to know how Kubernetes scales from an application perspective. That's our whole goal. So here's an overview of most of the scalers that we have. Well, the vendors, but we have more than that. And as you can see, we're basically covering a lot of the major ones, and we are always adding more scalers. So if we're missing something, just let us know. It's also good to know that you can build your own scaler which we can consume as an external scaler, but I'll talk more about that later on. So how does it work? So we have a cluster installed with the KEDA in it. So we have a KEDA operator with autoscalers. And then you have an event source that you want to scale on. In this case, it's a queue. Can be Redis, can be a database or whatever. So then you create the deployment of a scaled object. Basically, the scaled object defines what you want to deploy, what you want to scale, and how. So at the top, you see the scale target ref. That's basically referring to the deployment. Okay. If the deployment contains multiple containers, we have an optional field for you to allow to specify the name of the container to scale. Well, the container not to scale, but to check environment variables on. Then in terms of the triggers, you can then specify one or more. And then based on the type, we have some metadata that you have to provide. So in this case, we're scaling on a Kafka topic, where It's located on localhost 9092, and we want to use consumer group my group for the test topic. And if there is more than 50, if we reach the 50 threshold, then we will basically start scaling. So you have full control. You can also check the polling. We have more optional fields like what's the minimum instance count, maximum instance count, the cooldown, etc. So it's all in your hands. You can fully tweak it, but we will do all the heavy lifting for you. Okay, so we will take that scaled object and deploy it next to a deployment. And since there's no workload on Kafka, we are scaling to 0. So then KEDA will see the scaled object. It will check how many events are there, and then it will basically start scaling up the deployment because there's work. And then based on the amount of work, it will automatically add more instances. And it's important to note here that we are not reinventing the wheel. We are simply providing the metrics to the Kubernetes metrics API, and we are automatically creating an HPA for you behind the scenes. If there is no workload, we will automatically delete the HPA and scale the deployment to 0. So that's what KEDA does. It provides the metrics, it creates the APA, and it will basically leverages scale to 0. So a bit more high level. So it's fully built on top of Kubernetes, and it acts as a metric provider, feeding the HPA and providing the scale to 0. KEDA itself contains the metrics adapter. We have a controller and then all the scalers. All the scalers are in charge of basically checking the systems. If we see that there is no work, we trigger the scale to 0 or 0 to 1 deploy scaling action. If there's more than, if there is work, basically we create the HPA, which then takes over to scale from 1 to n, basically. We have external scalers, out-of-box scalers, as you mentioned, and it's very easy to install it with Helm. We also support operator framework. We also have raw YAMLs if you want to deploy that. So it's fully up to you to decide how you want to use it. So we were in this scenario without KEDA, but if we have a look what it looks like with KEDA, we basically have one unified metrics adapter, and instead of having to worry about HPAs, you can just write the scaled object who knows how to scale everything. It's a CRD, so you can fully manage. It's a scaled. It's a native Kubernetes object then. Okay, so if we come back to this look, basically we replaced the custom metrics adapter and the HPA with KEDA as one component, and you will see that once the work starts winding down, it removes the whole workload, allowing us to cut one node, and if work pops up again, we just add more resources. Okay. Before I jump in the demo, there is a question about how do you secure KEDA against DDoS. I think you're more talking in terms of an of an HTTP scenario. It's very simple. We just do what you tell us to do. So if you don't put a maximum instance count on us, then basically we will keep on scaling based on the traffic. If you put a maximum on it, we will just stop scaling after, let's say, 20 instances, and that's it. Now, I don't think it's really KEDA's responsibility to protect the cluster against the DDoS. I think that's more on an ingress level, but feel free to clarify the question if my answer doesn't make sense. And there's a question if I can provide the slides afterwards. I will definitely do that. So I will upload them to SlideShare and I will tweet about it. So Okay, let's see this in action. So I have, in this case, K stands for, let me actually increase the font. I always forget what it is. Feel free to post if it's not clear. Just go with whatever. Okay, so K stands for kubectl. It's just an alias, but if I do a git deployment, you'll see that I have an order processor, which is basically following a service bus queue and doing some work. I have a order web front end, which I will leave out of scope for now. But basically, this is the application we have. And then above that, you can see that we have KEDA installed, which has the operator and the metrics API server. And I simply installed this with Helm. So here you can see that I've installed the 1.4.0 version, which is one from this week, actually. So the 20, no, this is installation. So it's just as simple as doing a Helm install like this. If you have the repository in your lists, and that's it. It's fully configurable based on your needs as well. So if you go to Helm Hub, actually, let me show you that. So here is the blog post that I mentioned. Feel free to give it a read. So if you go to Helm Hub and just search for KEDA, you will be able to find us here. So we don't publish a README anymore. That's going to change soon, which then lists all of the configuration options that we provide. If you want to learn more on how to deploy KEDA, you can go to our website. We have a whole deploying KEDA section on how to get started. Now the demo that I will do is also available for you. So it's actually a tutorial that you can use to autoscale a .NET core worker based on service bus queue. So you can just follow along. It's in our organization and do it yourself. So I will show you that now. So I have the deployments up and running. For here, I have no scaled object defined, so I can show you that scaled object. See, none. This is being installed when you install KEDA as well. So what will I do? So I have a scaled object here. And let me zoom a bit for you guys. Where I want to scale my order processor. In this case, I'm saying max replica count is 10 and wait for 5 seconds to scale back down when there is no work. We are going to scale with the Azure Service Bus scaler. And it basically only needs to know what the name of the queue is that it needs to monitor and what the length is. So as there are 5 or more messages on the queue, it will basically scale out. And then here you have 2 options. So either I fully configure over here how to authenticate, because it can look up the connection from an environment variable on the container itself. Let me actually show you that. Everything is documented. Here you can see all the scalers that we have. So if I go to Service Bus, you can see that I could provide a connection. And that connection basically then looks up not the raw value, but a environment value on the container. So you could reuse the same connection string. We allow you to use trigger authentication, which was more of the enterprise grade security that I mentioned. so that you can decouple the authentication for KEDA from the container, meaning KEDA requires management access, while my worker just needs listen access to pull the messages. So by using the trigger authentication, I can give KEDA more permissions than my workload by basically separating the authentication concerns. So here I have a trigger authentication, and I'm just saying, hey, for the parameter with name connection, instead of going to an environment variable, just use the secret, which you can see here. Okay, we have more than support for secrets, so I will show you that. It also explains what the benefit is, but basically we have support for environment variables, secrets, and pod identity, meaning you can authenticate to Azure. Let me look at the real list. So Azure pod identity, EKS pod identity, and KM pod identity. Basically allowing you to no longer have to add secrets in 4KEDA. Now, the other benefit is that if you have 5 workloads who need to autoscale on the same service bus namespace, instead of duplicating that secret on each deployment with management permissions, you can create one trigger authentication and reuse that on all your scaled objects. So it's a bit of a more flexible approach. I personally prefer that because it moves away the authentication outside of the scaled object. But that's basically how simple it is. Just point to what needs to be scaled, how it needs to scale, and based on what it needs to scale. Over here, we tell it how to authenticate. Okay. Let me pull up my command lines again. So I will do an apply. I will simply add those 3 things. So as you can see here, I will do a K scaled objects. And you can see here that it has the same name. We're targeting our order processor deployment, which you see here, and we're using the service bus trigger. If I do a trigger authentication, you can also see the same. Let me check if the white shows more. Nope. But basically, this is what it will use to authenticate with. Okay, so if I now do a get deployment again, you will see the first thing is that KEDA already scaled it to 0 because there is no work on the queue, and I can show you that. Nothing to process here. Okay, and now it's time to see an action. It was just as simple as adding a scaled object. Over here, I have a tool which will basically add a lot of messages. So let's just add, let's just with 75. This one will start queuing it. Whoops. Okay, and here I will do a K deployment white. Watch, sorry. See that the messages are starting to pop up, and in a second you will see that over there, KEDA is already adding instances. If I do one again, you see that it's already assigning 4 instances to cope with the work. And then over time, when the work is starting to wind down, you will be able to see that it will already scale them down. And you see that it's not processing them fast enough, so it's just adding more instances. And then once it sees that the work is almost gone, it will automatically scale them down. So in this case, I'm using a deployment where it's just a daemon constantly running. So here it makes sense that we just scale out horizontally. With the job, however, it will, in the version 2.0, it will be more streamlined so that one message on the queue is processed by one job. This already works with jobs today, but it's sometimes a bit confusing because it's mixed with the deployment. So you see that everything's processed, and KEDA already scaled it back to 0, which is, in my opinion, very powerful. So that's how simple it is. I just have to deploy my scaled object, optionally use a trigger authentication. It's not enforced. It automatically scales it to 0. Once there is work on the queue, it automatically scales it out for you based on how you defined it, and then it will automatically scale it down once it's ready. So we have a very nice community. We already have 1.8 stars on GitHub and more than 50 contributors from a variety of companies, and I think we're even around 60 today. And we have bi-weekly community stand-ups. So if you are interested, you can just join these. More information on our website, and we already have a nice variety of customers. Now, this is another nice project that was started by Microsoft, and if you have a look, they're really working on a lot of cool stuff. And it's really definitely worth to check out what they're doing, because, for example, KEDA works well with Helm. It works well with virtual kubernetes because with virtual nodes, you can scale outside of the cluster, which you might need with KEDA. And we are also integrating with service mesh interface because that basically makes it easy for you to auto scale based on service mesh workloads. So just a small word on Azure Functions. With KEDA, you can basically bring the Azure Functions experience in Kubernetes and auto scale it with KEDA. It's the same experience from a developer perspective, and basically you can now just run and scale Azure Functions wherever you want. Now, in terms of roadmap, there's a lot of things we want to do, but one of the biggest one is native support for HTTP workloads. So as of today, you can already scale HTTP workloads, but you have to provide the metrics through something like Prometheus, who's measuring the ingress, or soon you will be able to use the service mesh interface scaler that we're building, but we really want to make it that simple for HTTP workloads as well. We're starting to build an ecosystem around external scalers, meaning that KEDA ships with a set of scalers out of the box, but we're seeing that more and more people are using our external scaler feature, which basically goes and fetches the metrics outside of KEDA by using gRPC. So if we do not support a scaler yet, or you have an internal system or metrics provider, you can build an external scaler around that. And we are basically starting to grow an ecosystem on top of that. So if you go to KEDA Core external scalers, we already have 2. It's not that many, but we will add more once they start popping up. So if you have one, just let us know and we can add a link here. If we see that the community is really embracing one of these, we can even evaluate to make it part of our core. We're working very closely with the Knative people as well to provide seamless integration because they want to use KEDA to scale their workloads as well. And then we are also introducing new scalers. We recently introduced Azure Monitor. We're now working on Service Mesh Interface, Redis Streams, and another one that's on the roadmap is Azure IoT Hub. But we are always open to add more of them. So if you want to have another one, just let us know. And with that, I've reached the Q&A. So if you have questions about KEDA, Kubernetes scaling, want me to go back to the demo and show something else that was not clear, just let me know in the questions. I'm not seeing any questions, so either I did a good job or everybody is sleeping. In the meantime, I will upload the slides already so that I can give you a link here. Let me see. No questions. Okay. And I will share the link and call it a day, unless somebody asks a question now. No. Okay, so here are the slides. Thank you very much for joining. And if you have a question later on, don't hesitate to open an issue on GitHub or ping me on Twitter. Thank you. And there is a question. Are there plans for RabbitMQ? That's a good question. I thought we had it. Yes, we have support for RabbitMQ. So I will post a link to it. Last chance. Whoops. Okay, thank you very much and see you later.